Alright, so today we're going to go ahead and start the Honors Pre-Calculus Marking Period 3 RQA Review number 1. And I'm going to start with number 1 that is asking us to use fundamental identities to explain why the graph of cosine of pi plus x times negative cosecant of x, why that graph is equal to the graph of just cotangent of x. Okay, so essentially what we're going to do here is we're going to prove, using fundamental identities again, that this expression is equivalent to this expression. Okay, so there's a few different identities we're going to use. First off, we're going to use the sum identity for cosine of x for multiple angles, specifically 2. So if you don't recall, that formula says the following: cosine of alpha plus beta, where alpha and beta are angles, is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Okay, again, where alpha and beta are any two angles. Okay, so here I'm going to let alpha equal the angle pi radians, or 180 degrees, and I'm going to let beta just equal the angle x. So we're just kind of trying to match it up with this formula up here, with pi being equal to alpha and x being the same thing as beta. Okay, so let's go ahead and start this. So I'm going to say cosine of pi plus x is equal to, well, following this formula here, if alpha is pi, then I'm going to have cosine of pi, and if beta is x, cosine of x. So again, we're just kind of matching it up with what we have in this sum of angles for cosine of x minus, and then on this side we have the exact same thing but with sine, so sine of pi, sine of x. Okay, and then we're just going to use some things that we know from the unit circle. Cosine of pi is -1. Okay, so I have -1 times cosine of x, because we don't know what x is, so I just leave it there. Okay, and then we have minus, well, sine of pi is 0 times sine of some angle x. So this will be canceled or go away because that's equal to 0, so I'm just left with negative cosine of x. Okay, so what I've done here is I've taken this first part of the equation and simplified it just to negative cosine of x. Okay, so we're going to go ahead and continue this on the next page. And so now, my original question, I'll just write it up top here, was cosine of pi plus x times negative cosecant of x. We're trying to show that that's equal to cotangent of x. Okay, and we just showed that this is equivalent to negative cosine of x on the previous page. So then we have negative times negative cosecant of x. Okay. So now if you look at this, we have negative cosine of x times essentially -1 over sine of x. Okay, because cosecant is the reciprocal trig function of sine. Okay, so cosecant is 1 over sine, sine is 1 over cosecant. Okay, so I can write that there. This is a times. And then I can combine these and have negative cosine of x over negative sine of x. Okay, this negative sign here I can apply either to the top or bottom. I chose to put it to the bottom. Okay, a negative divided by a negative is a positive, and we know that by definition of cotangent, cotangent is cosine over sine. So this is just cotangent of x, which is exactly what I wanted to prove. Okay, so if I can show that these two sides of the equation are equal to each other, which is what I just did, then obviously their graphs are also going to be the same. Okay, so there's number 1 on the review for the RQA. We're going to go ahead and continue with number 2. Okay, so for number 2, it says John was asked to find all the solutions to the equation sine of 2x equal to negative root 2 over 2. Okay, just as kind of a note here, remember that root 2 over 2 is equivalent to 1 over root 2 if you're looking at a different version of the unit circle. Okay, and they say that they want x to be between 0 and 2 pi, including 0 and 2 pi, if those are answers. And then they give me this information that he's already found two solutions, 5 pi over 8 and 7 pi over 8. Okay, so they've already actually done that work for us, and they're saying Paola says there are 4 points of intersection, so there are 4 solutions. But here again, they've only given us 2, so our job is to find the other 2 solutions. So just as kind of a walkthrough here, let's talk about how they found these answers in the first place. So remember the process for solving equations like this, where you have multiple a multiple angle inside of a trig function. In other words, there's a number here next to x. Is you kind of simplify the equation and you just find, in this case, where is sine of x equal to negative root 2 over 2. Okay, so if you go on the unit circle, you would see that the angles for that are 5 pi over 4 and 7 pi over 4, right? So that's just for sine of x equal to negative root 2 over 2. These are both in quadrant 3 and 4. Okay, but then we have to kind of update our equation here and put a 2 next to it because there's a 2 here. Okay, and then if you divide by 2 on both sides, which is the same thing as multiplying by a half, okay, that's where you get the 5 pi over 8 and the 7 pi over 8. So that's how he got those first 2 answers, just kind of as a side note to review that. So to find the additional answers, because they say that there are answers, or they want answers between 0 and 2 pi, well, if you look at 7 pi over 8, that's a little less than pi, right? 8 pi over 8 would be equal to pi. So I still possibly have answers here, and that's what they're telling us to find. So to do that, I need to use the period. So just as a reminder, the period for sine of x, or the formula for that, is 2 pi over the absolute value of b. It's the same for cosine as well, and for tangent it would just be pi over the absolute value of b, where b in this case is 2. Okay. So if I know that that is b, then my period for specifically, let me get a different color, the period for sine of 2x would be 2 pi over 2. 2 is already positive, so I don't need the absolute value, which means the period for sine of 2x is pi. So what I need to do now is I need to add to each of these 2 answers an increment of pi. So I'm going to do that on the next page. So we have 5 pi over 8 is our first answer, and we're going to add the period, which was pi. Okay, so pi I can also write as 8 pi over 8, like we mentioned before. Multiply this by 8 over 8 to get a common denominator of 8. So you get 13 pi over 8. So there's the third answer. And then likewise, if we do 7 pi over 8 plus pi, again, that's 7 pi over 8 plus 8 pi over 8 to have a common denominator, which is 15 pi over 8. So there's our fourth answer. And just to kind of recap what we've been talking about here, remember you're only going up to 2 pi. So in this case, I'll make a note of this. 16 pi over 8 is equal to 2 pi, right? If you simplify that. So if you look here, this is the final answer that I could list, because if I add another increment of pi to this, I go over the answer domain that they wanted, right? I go past 2 pi. So I definitely will stop here, and these are the 2 additional answers that John needed to find. Okay, so there's number 2 for you. We're going to go ahead and move on to number 3 now. So number 3 says find the value of side A. Your answer should be corrected 3 places after the decimal point. So let me just kind of sketch this triangle that I'm given here. So this is B, which means this is angle B. This is side A, which means this is angle A. And we can just label this angle C and side C. Okay, and they tell us that C is 110 degrees, B is 50 degrees, and since we know that a triangle is sum of the angles must be 180, we also know that A must be 20 degrees, right? Because 20 degrees plus 110 degrees plus 50 degrees is 180, which is what a triangle's angle should add up to, okay? And then they also give me that side C is 12, right? So here what I'm going to do is use the law of sines to find side A. The reason I can do that is because I know an angle and its associated side, and I know another angle, and I'm looking for the side that's associated with that, okay? So I'm going to say side A over sine of angle A, where angle A we just said was 20 degrees, is equal to side C equal to 12 over sine of angle C, which was 110 degrees. Okay, so I'm going to use my calculator here, make sure you're in degree mode, and I'm going to multiply both sides by sine of 20 degrees so that these cancel. Okay, what you do to one side of an equation, you have to do the other. Okay. Okay, and then if you do this in your calculator, let's see what we get. We get 4.368. Okay, and they wanted us to round to the nearest thousandth, or 3 places after the decimal. So that would be the length of side A. Okay, so there is problem number 3, and we're going to go ahead and move on to number 4. Okay, so problem number 4 is a multiple selection question. So which of the following is an example of a vector in terms of notation? Select all correct responses, and then they add this additional piece. If any of the selections represent a scalar, say so next to that option. Okay, so the first option is, if you can't tell, it's a bold V. So that's my best drawing of a bold V. Okay, so that is a vector in terms of notation. Okay, remember, if you see a letter that's in bold, that's referencing a vector. The second option uses the ray symbol, often seen in geometry, which also represents a vector. So this is also a vector using that ray notation. The third option is also a vector that is in component notation. Right, that's probably the most frequent we see because we want to use the x and y components of a vector. Okay, so the last one is not a vector. Okay, and this is actually the scalar. Right, so a scalar in terms of vectors is just simply a number. In other words, something that's not a vector. Okay, so there's number 4. So the answers were these first 3. Okay, and then again, number 5 is a scalar. Let's go ahead and move on to number 5. This will be the last one we do in this video segment. So it says vector f shown below is defined in terms of vectors s and z. I'm just going to try my best to redraw this here. Okay, and I actually don't care about the specific endpoints of the vectors because they're just asking us to draw or write the sum of 2 vectors and with another vector being the resultant vector, just kind of visually here, geometrically. So if you look here, the options that they give us are first, let me just write the options. So A is f equals s plus z. Okay, just for the sake of time, I'm not going to put all the ray symbols over the vectors. We know that they're vectors, right? F equals s minus z. C says f equals negative s plus z. And finally, D says f equals z minus s. Okay, so let's go through some of these. Notice, first of all, that all of them are saying that the resultant vector is f. So I need to do some combination of s and z to get this vector f. So if I look at the first one, if I do s plus z, well, s, and I can actually draw it here. So if I do s plus z, well, using the head to tail method, I would have s, and then I would say plus z, right? So this would be the z vector if we kind of take a copy of this and put it up here using the head to tail method, and the resultant vector would be here, right? Well, that's obviously not f, right? F is all the way up here. So let me just erase those. Okay, so A is out. Okay, now let's look at B. If I do, let's see, F is equal to S, so same as the first option of A, S minus Z. Remember that, I'll make a note of this, F equal to S minus Z. That's the same thing as S plus the negative version of Z, right? So if I look here, if I have S, and then using the head to tail method, I take the negative version of Z and put it up here, that exactly gets me to F, which is what I want, right? So I would have negative, I know that's not the perfect line, but that would be negative Z, right? Which gets me to the resultant vector of F, which is what I wanted, right? So in this case, my answer would be B, okay? And I don't even have to worry about the other ones because it's multiple choice. There's only one correct answer. Okay, so that finishes up number 5, which is the front and back of the first page of the Honors Pre-Calc Marking Period 3 RQA Review number 1. Thanks for watching, and we'll continue in the next video.